Hi everyone. Today we are looking at an economics application, elasticity of demand. Now let's talk about this. Elasticity of demand the abbreviation for it is E of X, measures the rate that quantity demanded changes when we change the price. Okay, so essentially the question is, if I change the price on this object, what's going to happen to the demand? We know in general, if we lower the price, the demand goes up. If we raise the price, the demand goes down. But elasticity gives us more specifics about that. Now, there's a formula for it. Let me show you where the formula comes from. So what we're doing for elasticity is we're going to measure the percent change in quantity demanded over the percent change in the price. Now, that little triangle in the middle, delta, that's for change. So the percent change in quantity over the percent change in price. Let's let X equal the price. And we're going to write D of X for the demand. That's the quantity. And of course, we're using D for demanded. Here, we'll just put in parentheses demand. Okay, so we've got that percent change in quantity over percent change in price. Well, percent change in quantity is the change in quantity over what the original quantity was. That's how we find a percent change. Similarly with price, but I'm using X for price. So it's the change in price or the change in X over what the original price was. Now, obviously, we can do a little algebra here. Change in quantity over quantity times, remember when we divide by a fraction, we invert and multiply. So now it's X over delta X. And then I can rearrange some things. Let's do X over Q times delta Q over delta X. Now, one thing that we know, remember X is the price, Q is the quantity. But since the limit as X goes to 0 of delta Q over delta X, that's by definition the derivative. So that's going to be dq dx, or we're just going to write it as it's demand. I don't want to write quantity anymore. Remember, the quantity was d of x. So since that's the rate of change or the derivative of quantity, we're going to write it as d prime of x. And so we can say, okay, this as X goes to 0 becomes, well, X was the price times the dq dx becomes d prime of X all over d of X. Because remember, the quantity demanded, Q, is really d of X. That's essentially our formula for elasticity. Now, they do one thing with that. Here's what they're going to do. In our book, our author doesn't like that to be a negative number. So for elasticity, and we'll even call it elasticity of demand, that's what it is. E of X. Now, if we go back up here where I've circled this, remember, X is the price, d prime of X is the derivative or the rate of change of demand at that price. And then the bottom is the demand. Well, X is price, so it's positive. D of X on the bottom, that's the demand quantity, that has to be positive as well. D prime of X says, well, what happens to the demand when I increase the price? Well, again, remember, if the price goes up, quantity demand goes down. If price goes down, quantity demand goes up. So that D prime of X is always negative. Our author doesn't want this to be a negative number. In economics, I think it's typically a negative number for elasticity. Our author doesn't want it to be negative because then he has to worry about absolute values when he defines things. So he puts another negative in front of that to cancel out the negative from the D prime of X. And then he's going to list the formula as negative X times D prime of X all over D of X. That's going to be the formula for elasticity. So we need to remember that, but remember what it represents. It's the percent change in quantity over the percent change in price. In other words, when we change the price a certain percent, what percent does that change the quantity? Okay, so we have elasticity, and there's a couple things we need to know about this. One, if E of X is less than 1, we call that inelastic. Demand for some products is inelastic if we change the price a certain percent, but the quantity changes less. So if there's something in great need, one of the classic examples they use is insulin. People need to buy insulin if they're diabetic or they're going to die. Well, so what they're going to do is if the price goes up quite a bit, they don't have a choice. They're still going to buy it. They may not buy as much because they can't afford it, but as many people are going to still buy it that need it. And so price can go up quite a bit. Quantity demand is not going to go down as much as price went up. That's inelastic. If E of X is greater than 1, that means the quantity demand is going to change a lot more than the price did. So if there's readily available substitutes for some product, say I go to the store and I want to buy a can of beans, and there's 2 different types of beans, 2 different brands, same kind of bean, but 2 different brands. And one's a little bit cheaper, but I don't really have a preference between the 2 brands. I'm going to buy the cheaper one to save some money. And so a lot of people will do the same thing. So the price changed a little bit, but the quantity demanded changed a lot. So that would give you an elasticity greater than 1. That's called elastic. And then lastly, if E of X is equal to 1, we call it unit elastic. And so these we should know. And let's think about if we're trying to maximize revenue. To maximize revenue. So let's see, let's go in order. If it's inelastic, if the demand's inelastic at some price, what we want to do, remember, we can change the price a lot. The demand's not going to change much. So we want to increase the price to make more revenue. So if it's inelastic, increase price to maximize revenue. If we are elastic, if demand's elastic at some price, then what we want to do, remember in that case, we can change the price a little bit, but the demand changes a lot. Well, in that case, we want to lower the price a little. We'll sell a lot more of the product and make a lot more revenue. So if it's elastic, we want to decrease the price. And I'm just going to put quotation marks here to maximize revenue. And then lastly, if unit elastic, then we're already at the price that gives us maximum revenue. So if Unelastic, we're at correct price to maximize revenue. And so we can use that last one that would say this: in order to maximize revenue, set E of X equal to 1 and solve. The solution X is the price we need to maximize revenue. All right, so that's the lecture for the entire section. What we have left, I'm just going to do 3 examples. So we'll see 3 examples, see how this all works, and hopefully that'll give us a good idea. Okay, so the first 2 I just have in here. Problem 4, and I'll write down what they give us. They say the quantity, D of X, remember that's how we define the quantity, is 500 minus 2X. That's my formula. And they give us an X equals $57. And so the question says, A, find the elasticity. Find elasticity, E of X. All right, so in our formula, E of X, negative X times D prime of X all over D of X. And so we just plug it in. So negative X, well, the derivative of 500 minus 2X is negative 2. Over the original function, 500 minus 2X. So I get on top, negative X times negative 2 is positive 2X over 500 minus 2X. That's my elasticity. If we want to factor out a 2 to simplify it, we can. So we'd say that that's 2 times X, that's 2 times 250 minus X. Now the 2's cancel. Remember, we can't cancel until we can factor it out. So maybe we won't write it that way. That would be our simplified form, X over 250 minus X. So there's my elasticity. All right, part B says, find the elasticity at that given price, in this case $57, and state whether demand is elastic or inelastic. So that X equals 57 up here, that's what they're saying here. Find elasticity at X equals $57. So we'll do that. We just plug it in. We say, oh, that's the 57. So we get 57 over 250 minus 57. What's that? 57 over 193. Let's get that as a decimal. I get 0.295. That's our elasticity. Since that's less than 1, we say it's inelastic. Now, we know from what we talked about before, since it's inelastic, we want to increase the price to maximize revenue. Well, that begs the question, well, what do we want to increase the price to? That's what part C says. Part C says find the price to maximize the revenue. Find price to maximize revenue. My claim is it's going to have to be more than the $57 because we said demand was inelastic at that price. Well, let's see. So remember, to do that, we set E of X equal to 1 and solve. So let's see. So we had what? X over 250 minus X equals 1. We're going to multiply both sides by the 250 minus X to clear my fraction. So those cancel. And I get X equals 250 minus X. I'll add X to both sides, and I get 2X equals 250. Divide by 2, I get X equals $125. Clearly more than the $57 that we checked. So we want to increase the price to $125. That's going to maximize my revenue. Okay, so not too hard. We had 3 parts there. They went fairly quickly. We had easy algebra in that problem because I wanted to show you the idea about the elasticity. But here's one thing I want to say about this. This number right here, that's my elasticity. That actually means something specific. So that would say something along the lines of, let's do this in another color pen. If we say increase price 1%, demand, now remember we put that negative in there to change the signs, but they're going in opposite directions. Demand will decrease by 0.295%. So that's actually a number because remember, elasticity is the rate of change of demand divided by the rate of change of price. And so all I did with that one is I made that a fraction over 1. And so the top represents the rate of change of demand. The bottom represents the rate of change of price, or the percent change, not the rate of change, excuse me. I'm going to erase those so that we still have that 0.295. But I could say, oh, if I increase price 2%, then I would double the 0.295, multiply that by 2. Okay, but it's for small price changes because we have to, if it was a big price change, if we're going up to $80, well, then we have to do E of 80 and it's not going to be 0.295 anymore. Okay, let's try another one of these problems. Let me go ahead and box this though, because I'm a big fan of understanding what that elasticity value actually means. Okay, let's go into another problem though. It's problem 8 in the book. Q, which is the demand, is the square root of 300 minus X. And this time they give us an X equals $250 that we're going to check for the demand. All right, so again, A, find elasticity. Same question as before, just a different demand function. Elasticity. All right, so E of X, negative X times D prime of X over D of X. All right, let's see. So let's think of this as 300 minus X to the 1/2 power. And so when I take the derivative of that, so I've got my negative X times 1/2 300 minus X to the negative 1/2, but then times negative 1, that's the chain rule, that's the derivative of the inside function. It's really important that remember that negative 1, otherwise it's not going to cancel the negative in the front. And then the bottom, I'm going to leave it as 300 minus x to the 1/2, and I will show you why for simplification reasons. Okay, so let's see what happens. This negative got canceled out by that -1. I'm going to do this. Remember, this piece to the -1/2 power, that brings the negative power, the negative exponent brings it down to the bottom. So when we go to the bottom, I can rewrite this way. So e of x equals, now notice, first of all, big fraction, here's our 1/2. So that 2 just goes down on the bottom. We have also got an x. Now, we already had a 300 minus x to the 1/2. We brought that one that I put in blue down here also. 300 minus x to the positive 1/2 once it gets down there. And so that's everything that I had. Now, one thing to notice about these two, remember when you multiply things with the same base, you add the exponents. Well, so that's just going to be 300 minus x to the first power, or just 300 minus x. So this whole thing simplifies to, I don't need the 1 on the top. The 1x is just x. The bottom is 2 times 300 minus x to the first power, or just 300 minus x. So it's simplified really nicely. And that's my elasticity. I'm going to leave the 2 factored out on the bottom because why not? All right. And remember, we're checking it at $250. So B, the elasticity at $250. So I go 250 over 2 times 300 minus 250. Well, the top's 250. Notice the bottom in the parentheses, that's 50. 2 times 50 is 100. So I get 2.5. That's greater than 1. So I say, oh, this time it's elastic. And in fact, what I want to do this time is I want to decrease the price. To maximize revenue. And we'll show that in part C again, but again, let's interpret this. If we, and we'll do it the same order we did last time. What did we say? Increase price, so still increase price. So I don't want you to think of that as being something different. I don't want this to be here at all. Okay, if we increase price by 1%, demand will decrease by 2.5%. So that's what I'm saying. A small increase in price leads to a big decrease in demand. Now, we said we want to decrease the price, so we can flip it and say it the other way. If we decrease price by 1%, demand goes in the opposite direction, so demand will increase by 2.5%. That's why we're going to want to decrease the price. Well, let's see. We had $250. Let's see what price would give us maximum revenue. So part C, find the price to maximize revenue. All right, let's try it. So we're going to set E of X again equal to 1. We want unit elasticity. Well, E of X, X over 2 times 300 minus X. Again, multiply by the denominator. I'll go ahead and distribute that out at this time. So again, those will all cancel. I'm going to get x equals 600 minus 2x. Add the 2x, divide by 3. Yeah, it was true. I did want to lower the price. The price before was $250. We saw, oh, at $250, demand was elastic. Oh, let's decrease the price to what? $200. At $200, elasticity will be unit elastic, and I'll have maximum revenue. All right, so let's do one more application. This one's a word problem, and there's a few parts to it. Well, it's only got A, B, and C. But I wanted you to see a different type of function. So let's go, actually, it's just right there. Well, we'll go in here and grab it. It's this problem right here, problem 15. So we'll copy that there, paste it in here. Says, oh, no, you won't. Paste. Nope. All right, try again. Here, let's just go to the snipping tool. So there's the problem. We'll copy it there and paste it in here. All right, so demand for computer apps. Highwire Graphics determines the following demand function for a new app. So they give us the function, it's an exponential function, where Q is the number of apps sold per day when the price of X dollars per app. They give us a graph of it. Find the elasticity when X is 3, and then at $3, will a small increase in price cause total revenue to increase or decrease? Good question. So let's see. So first of all, let's find the elasticity. So E of X, again, remember the formula, negative X times D prime of X over D of X. So let's see, E of X equals negative X. Let's see, D prime of X, I'm going to get back the entire exponential. But the chain rule says times the derivative of the exponent, which is the negative 0.12. Again, I get that negative back. So what I'm going to do, oh, we might as well finish all over D of X, which was 50 e to the negative 0.12x. Here's one thing that's nice about elasticity when you have an exponential. Since the derivative, you always get the exponential itself back times some constant, those exponentials just cancel each other out. Like, wow, that really simplifies things quite a bit. So what I'm going to get, now I'm multiplying the negative 0.12. Oh, I was going to multiply by the 50. There's no 50 to multiply by. I just canceled it out. Never mind. So the negatives are going to cancel, and I just get E of X equals positive 0.12x. Everything else canceled out. So now when I do this one, well, there's my elasticity. It says find the elasticity when X equals 3. Well, E of 3 equals 0.12 times 3, which we can do that in our head. That's 0.36. And again, if we do 0.36, that's less than 1, so it's inelastic. And remember, what we want to do, if it's inelastic, is increase price to maximize revenue. All right, and then for part C, let's see, this was part B. For part C, they say at $3 will a small increase in price cause total revenue to increase or decrease? Well, we want to increase price to maximize revenue. So we would say in this case, oh, we increase price. So will a small increase in price cause total revenue to increase or decrease? Well, revenue will increase if we increase the price. So that's it. There's 3 examples. Hopefully that works for you. We had a polynomial first of all, and then we went to a radical, and now we've seen an exponential. So you've seen some various types of these, but understand what elasticity means. Remember where it comes from. It's the percent change in quantity over the percent change in price. In other words, if I change the price a little, what's going to happen to the quantity demanded? Okay, so hopefully that helps you out. Hopefully that works. That'll give you some stuff to work on. And if you have questions, of course, just ask in the live sessions and I'll be happy to help you. Best of luck, and I will talk to you again soon.